Good afternoon, everybody. Welcome to this session. My name is Tobias, and I'm going to take you on a journey for building serverless backends for mobile apps with Azure Functions and Cosmos DB. Throughout the session, if you have any questions, please feel free to write them down in the chat so that we can get back to them after this session. I'm also going to join the Q&A session after this, and so if there's any further questions that need some in-depth discussion, please let's just join there for some further discussions. So let's start right away. My name is Tobias. I work as a software architect at the company softaware. We are located in Asten, Upper Austria, and we're building custom software solutions with Angular, .NET, and Azure. I like good coffee, motorcycles, and of course Azure, and I'm also holding 2 Azure certificates at the moment. So let's just jump right into it and let's take a look at our agenda for today. First, I'm going to give you a brief introduction why we're talking about this topic at all. Then we're going to take a look at how to adapt traditional database models for NoSQL, especially for Cosmos DB. And after that, we're going to talk about some special features that Cosmos DB offers when working with location-based data. Then we're going to take a look at authentication of Azure Functions with social providers like Facebook, Google, Twitter, and so on. Of course, in the end, there will be a recap and we will have some time to get to your questions. So right now, you just have to sit back, relax, and let me take you on this journey. I'd like to start right away with the question, why at all should we build serverless backends with Azure Functions and Cosmos DB? And for that, I'd like to tell you a little story how I ended up doing this. So as I told you in the beginning, I like motorcycles. And a few years ago, I decided to make my driver's license and got myself my first bike. And since then, I've been on a lot of different trips. Some of them were longer, others were shorter, but all in all, really beautiful. I had some good weather and also sometimes some pretty bad weather. It's just a great experience to ride your bike and enjoy the beautiful landscape. So when riding my bike, I realized that it's great, but actually riding together in a group is much more fun. So sharing this experience with other riders to ride a group together in a group is much nicer. So I thought about maybe I could find an app out there that could help me to get together with other bikers around my area in order to ride together. But unfortunately, when looking for an app that provides this feature, I couldn't really find one that supports this sufficiently. So since I'm a software engineer myself, I decided to just write my own app. And right now, I just want to give you a brief introduction of this little app I built because I'm going to reference it throughout this session. So I developed a small app called MotoMeet, and of course, as every app, we will start off with a login screen. So in this login screen, I can log in with 2 social authentication providers. In this case, we're using Facebook and Google. After logging in, I get presented all the trips that are going to take place in my area. So on the top, I have my current location, my current position, and I'm presented all the trips that happen, in this example, within a radius of 50 kilometers from Hauptplatz Linz. And if I select a specific trip now, let's select Ausfahrtberg, I can see all the trip details. So for example, when is the trip going to start? How long does it take? And where's the meeting place? Notice that in the bottom part, we can also see the participants of this trip. So who already joined the trip and is going to join this group ride. And you've now seen the front end. This app, I built this app with Flutter. What we've not talked about yet is the actual backend for this app. And that's what I'm going to focus on in this session. Because I built the backend for this app with Azure Functions and Cosmos DB. And that brings me back to my initial questions. Why should we do that? Now, after I've done that, I can tell you that the answer is pretty simple and obvious for me, at least. Because Azure Functions and Cosmos DB help me to really focus and think in features. So when developing this app, I really wanted to focus on the user functionality and not waste time with setting up databases, with setting up the web API and so on. Just every single line of code that I write should somehow contribute to the actual user feature. So that's what I ended up with, these two technologies. And whenever I build an app, I like to start with thinking of the data itself. So which data am I going to store? How and where am I going to store it? In this case, I used Cosmos DB for data storage. And just to bring everybody on the same page with regards to Cosmos DB, I want to give you a short introduction. Cosmos DB is a fully managed NoSQL database provided in Azure. It stores schemaless and unrelational data in JSON format. So this means the two JSON documents stored in the same container must not necessarily have the same properties or the same structure at all. When reading through the documentation, you will find out that Cosmos DB really stands for high availability and low latency. And it also provides multiple APIs for communicating with the database. The native API is the core SQL API, which we are going to work with throughout the session. But there's also MongoDB, there's Cassandra and Gremlin. And you can use that, for example, if you have already an existing application that is using, for example, the Gremlin query language, where you're querying some graph-based data. You could reuse your data access layer when switching to Cosmos DB. Of course, also let's talk about the costs. So when working with Cosmos DB, the charges for every single database query are calculated based on so-called request units, among other things. So every database operation gets assigned a cost using request units. And now there are different billing modes or account modes we can choose from. First, there's the provisioned throughput mode. So this means I reserve a specific amount of request units, and that's what I can use. And that's exactly what I'm going to pay for at the end of the billing period. There's also a serverless mode in which I can use as many request units as I want, and then just go and pay for that amount at the end of the billing period. And of course, there's also an auto scale mode, which scales the database automatically based on its usage. And this is useful for any mission critical workloads or some high availability requirements. But I've got good news for you. If you want to try it out, there's of course a Cosmos DB free tier, which offers you 1,000 request units per second per month for free. And that's actually what I went to. So I choose this free tier because during the development phase, this was totally sufficient for me. So now that we've talked a bit about Cosmos DB, let's talk about the data. And as I told you in the beginning, Cosmos DB also supports me, helps me to think in features. So why don't we just start out with a feature? I showed you this view. In this view, I can see all the trip details. I can see when it starts, where's the meeting location, and so on. And in the bottom part, there are the participants that take place, that they joined this trip. And if we now think in a traditional way, we can easily identify two entities. We have the trip with all its details, and then there's a reference to the participants, which are the actual users of the app. So all in all, we have users that participate in trips, right? And again, thinking in a traditional way, one could easily define an entity relationship model for this. On the top left, for example, there's our table user. On the top right, there's the trip table. And then there's another table for building the many-to-many relationship. It's as simple as that. But when switching towards Cosmos DB, we unfortunately end up, if we translate this traditional model, we end up with some pretty inefficient documents. Let's take a look. So these are sample JSON documents that we could store in our Cosmos DB. Again, on the top left, there's our user object. On the top right is the trip object, and the bottom part is our many-to-many relationship. And if we think of the feature again, I want to request all the data that belongs to a trip. So the trip with its details and all the participants, all the users that take place. This would mean that in the query, we would first request the trip, then make a join to our many-to-many data, and then make another join to our users table or document in this case. So there's a big problem right here with Cosmos DB. Cosmos DB does not support cross-item or cross-container joins. And instead, what we have to do is to go at the other way around, to step back from our traditional way of thinking, the traditional way of normalizing our data model, and go the other way around. In fact, it's called denormalization. So what we're doing here is we're going to take this many-to-many data and eliminate it, and instead put this information directly into our JSON documents. So as you can see on the right side, the trip already includes the participants themselves. And notice that we only include the data that is really necessary for our view. So the first name and the last name, because that's what I want to display on this view. On the left side, we have our user object, which also holds the information about which trips I already joined, which is Ausfahrtberg in this case. And why we do this and what benefits it brings us, I want to show you in the Azure Portal. So I'm going to open the Azure Portal right here. I've already created a Cosmos DB account, which I'm opening right now. And in here, if I select the Data Explorer, we can see that I've already created and put in there some test data. First, we open the traditional models database. In here, we have 3 containers, which exactly represents our traditional models. If we take a look at the trips, these are our trip details, right? Then we go over to the users. It includes the user details. And then there's another container, which holds our many-to-many relational data. Let's take a look. Yeah, there's the user ID and the trip ID. So since we cannot make cross-item or cross-container joins, if we want to now query the data that is relevant for our view, which is the trip details with all the participants, we would, of course, start off with the first query, which gives me the trip itself, including a few details. So this is a simple query where I'm looking for a specific ID that I want to open right now. And I end up with the general details, with the title and with the meeting location, the latitude and longitude. So this is fine. But now I want to have also the participants, the users that are going to join this trip. Therefore, I need to go to the many-to-many data, make a second query. Again, I'm looking for entries with the trip ID of the trip I just opened. And if I'm going to execute this one, I can see that there are at the moment 2 users that participate in this trip. What I'm now going to do is I want to remember these user IDs here, right here, because we now need to load the user data that belongs to this user ID. So we go into the users, make another query. We're looking for the IDs that we just found out. And if we execute this query, yeah, there it is. So finally, we have our user data. We have their first name and last name. And so this is the way we have to do it, since we cannot make cross-item or cross-container joins when we work with traditional models. We can also see that we have 3 queries in here. And if we take a look at the query stats, we can actually also see the request charge, which we are billed for at the end of the billing period. So the third query, for example, produced 2.9 request units. The second query produced 2.8 request units. And the first query also produced 2.8 request units. So in total, we end up with these 3 summed up. And what we now do is we're going to shift to the adapted models. Let me just close this windows. And let's take a look at how the queries change with the adapted models. So in here, I have only users and trips right now because there's no many-to-many data stored anymore. And if we take a look at the trips, they already include, as we talked about before, the information about who is going to participate in this trip. Of course, also the user includes this information, namely which trips he already joined. So what does the query look like now? If we want to select again for this feature all the trip details with the users, we just go to the trip container and execute one single query. We're looking for a specific ID, just how we started off with the other example. And if we select this one, we immediately, if we query this, we immediately get all the data that is needed for our feature. Isn't this cool? It's amazing. So let's go on. We just did the demo and take a look at the improvements we just achieved. So with the traditional models, we had 3 queries that we had to execute one after the other. The first one loading the trip details, then we had to resolve this many-to-many relationship, and then we needed to query all the user data that is associated. Of course, then we need to merge the data to have one single object and give it back to our client. So notice that we have 3 times the request units. After shifting to the adapted models, there's just one single query that we need to execute, which automatically includes all the data we need and is already in a JSON format, which I can immediately return to the client. So in fact, we made 3 big improvements here. We reduced the number of request units, which is good because we're going to pay less at the end of the billing period. We reduced the number of server round trips, so the actual queries for which I need to go to the database. And we end up with more efficient models because the trip is already in a form which I can immediately return to the client. So cool, these were already the first 2 topics from our agenda. And now let's continue with some special features that Cosmos DB offers when working with location-based data. Again, let's start with the feature itself. So I told you there's the login screen. And after logging in, I'm presented all the trips that happen within a radius around my current location. But what if I change the current location? Right now I'm at Hauptplatz Linz, and let's say I now drive to Amstetten. So I want to have a feature which helps me to actually change my current location. And after changing it, what I want is that this view adapts to it. So I will, for example, not see maybe the Ausfahrt Freistadt anymore. So how can we implement this in the backend? And if we take a look at our data, how it's stored at the moment, we can see that we are currently storing the latitude and the longitude in just JSON properties in there. So we're already having the geocoordinates of the starting point of our trip. Of course, we can also resolve these geocoordinates for our current location, and now we just need a way to calculate the distance between our current location and the starting point of our trip. And there's good news because, of course, you could do this in a mathematical way. There are ways to calculate distance based on this geocoordinate system, but I have some very good news for you. Cosmos DB already provides a built-in function for calculating the distance between 2 geocoordinate points. So on the bottom, I've put in a screenshot from the actual documentation. And this is the function that we're going to use. It's called st_distance. And if I provide 2 geo points to this function, it returns me the distance between these 2 locations in meters. Now, for using this built-in function, there's a specific requirement of how we should store our data in the database. So we need to store the data in the GeoJSON format. This is a specification everyone can look up on the internet. And after storing data in that way, which looks like this, we are able to use this built-in function with our data. So we now adapted our model again. And instead of latitude and longitude properties, we added a location object with a type, which is point in this case, and an array coordinates, which just contains my latitude and longitude. And now let's take a look at exactly this in the Azure Portal again. Cool. So here I'm just going to close this windows. I have another database created which contains some trips. And these trips are already stored with this GeoJSON point format, let's say. So I have my Ausfahrt Peag, and there's the Ausfahrt in Freistadt und Umgebung, and so on. Everyone stores it in this GeoJSON format. And if I now want to query all the trips around a specific area, the query itself is pretty simple. Let's just open up a new window. Query looks like this. So I'm selecting here all the trips within a distance of less than 50,000 meters, so 50 kilometers, where the distance between the starting location of the trip and my current location, which I put in right here, is less than this 50 kilometers. By the way, these coordinates are exactly the Hauptplatz in Linz again, if I remember right. So if we execute this query, we will see that we end up with 4 result objects, 4 resulting trips. We have the Ausfahrt in Perg, we have the Ausfahrt in Grein, we have the Ausfahrt, of course, in Linz, and Ausfahrt am Stitten. And just because I took a look at it before, one trip is missing, which is Freistadt. So we're going to extend our range here for, let's say, 100 kilometers, execute it again, and we can see that the Ausfahrt Freistadt, or the trip Freistadt und Umgebung, is now also included in our results. And it's as simple as that. So let's get back to our slides, and we are already done with 3 main topics of our 3 topics of our agenda. And this is already pretty cool, but now let's switch to the Azure Function part. This is also pretty cool, but let's start off with Azure Functions themselves. We're going to take a look at authentication with social providers, as I told you, with Facebook and Google. And just to bring everybody on the same page again, I want to give you a brief introduction to Azure Functions. So I like to think of Azure Functions as a form of compute on demand. So I have some logic that I implement in a block of code. I deploy this code somewhere in Azure. I upload it and deploy it. And every time a specific event occurs, this block of code gets executed. Now, in Azure Function context, these events are called triggers or function triggers. Azure Functions are serverless. This means that I have no work with infrastructure. I don't have to worry about infrastructure maintenance. And it's very flexible with regards to scaling. So it provides as many or as few compute resources as I need. There are many different types of function triggers. There's, for example, a HTTP trigger, which triggers my Azure function every time I receive a web request to a specific endpoint. Then there's the timer trigger, which can execute my Azure function automatically every 10 minutes, let's say. There's a service bus trigger that could execute my Azure function every time I receive an item in a service bus queue, and there are many more triggers. And for this session, I'm going to focus on the HTTP trigger because that's what we want to build. We want to build a backend, an API for our Flutter app, MotorMeet. Just to make this a bit more clearer, so on the one hand, we have some device that our app is running on, and this app initiates a web request. In this case, it makes a GET HTTP request to our Azure Function base URL, which gets appended /API and /users for querying all the users. And this call then triggers my Azure Function. In this Azure Function, I have some flexibility. I could, for example, look for some query parameters that have been provided in the URL. In this case, there is no query parameter. And what we're going to do is to call just our logic to load all the users that are requested right now, and then return them as an action result. So it's as simple as that. Let's move on to the costs and the billing part. There are actually 3 hosting plans I can use with Azure Functions. There's first the consumption and the premium plan. Both support automatic scaling, but one of the major differences is that the premium plan always provides pre-warmed function instances. So with the consumption plan, it could happen that if your function is not used for some times, it goes into something like a sleep mode. And then when an initial request is initiated after some time, the function could need a few seconds to get up and running again. This will not happen with the premium plan. And of course, there's another plan. You could also run your whole function app within a default app service plan, and you get charged exactly the same amount. Let's talk about the actual money, or in this case, what I went for was the consumption plan. And there's again some good news. You could use Azure Functions for free. And the free grant already includes 1 million function executions per month. And this was again totally sufficient for me. For my development purpose, and maybe even the first rollout phase. So now that we've talked about Azure Functions, let's take a look at how to integrate them into our backend scenario. The setup looks like the following. On the on the right side, we have our Cosmos DB, which stores our data with the adapted models. And on top of that, or in this case, besides that, we put our Azure Functions, which perform queries and manipulate the data in the database. If we go one step further, on the other hand, there's our app itself, the Flutter app that I built, which is performing HTTP web requests towards my function app. But wait a minute, something is missing. So these are web requests. We should somehow secure this connection, right? And in fact, yes, authentication is totally missing right now. And now I've, again, some good news for you. Azure Functions support some kind of built-in authentication, which is often referred to as easy auth. So this built-in authentication requires minimal or no code changes at all. And it works with multiple identity providers. It works with social providers like Facebook, Google, Twitter, and so on. But you could also use your organizational Azure Active Directory. With regards to login flow, it supports two login flows, the client-directed login flow and the server-directed login flow. And in this session, we're going to focus, or in this example, we're going to focus on the client-directed login flow, because that's what we want to do. It's only the job of the app itself, of the front end itself, to log my user in with Facebook and Google. And afterwards, we're doing some token exchange, which we are now going to take a look at in detail. So the client-directed login looks like the following. On the left side, we have our login functionality in the Flutter app. On the right side, there's our Azure function, which we want to communicate to, but in a secured way. And now a third instance comes into play, which is our social identity provider in this case. And let's just pick Facebook for now. Now, since this is a Flutter app, there's a library I'm able to use for building this authentication, which is called Flutter Fire, which enables me to use Flutter Firebase authentication. And this already does a lot of work with regards to logging in with social providers. So when everything works out by the use of Firebase authentication, I receive a social token. So I receive the actual access token from Facebook. This social token must not be a JSON Web Token. We will take a look at that afterwards. Now I would like to exchange the social token to something related to Azure in order to secure my communication with our function app. And after we enable the built-in authentication, the easy auth in the function app, we get a new endpoint that we can talk to. So there's a new endpoint which I can make post requests to, the base URL, which gets appended a /auth/login/Facebook, because we're using Facebook in this example. And the post request body contains our social token. What this easy authentication does in the background, it validates this social token against Facebook. And if this token is really valid, it returns me a new session token, which is our Azure session token that I can use afterwards. This response also includes the user ID, which is unique for this user within this context. So I've received my Azure session token, which I'm going to keep somewhere securely and going to use for every further requests to our function app afterwards. So in this case, I'm making an app request to /API/trips for getting all the trips. And now I include the Azure session token in the request header, which is called xsumoauth. Now, don't ask me why it's called like this. I don't really find out why. Maybe some of you can help me out on this. Now that we've talked about this in a theoretical way, let's take a more practical approach. And I'd like to again start off with the Azure Portal right here. Now I'm going to switch the resource group, and we're going to take a look at the actual backend for my app MotorMeet. So in here I have several resources, and we're just going to open up the function app. Yeah, here it is. Here's the function app, and we can see that I've already created several Azure functions in here, which correspond to the features of my app. But now if we take a look at authentication, we can see that I've already enabled easy auth for this function app. If this wasn't enabled, it would just be a toggle switch, which I have to move to from disabled to enabled. Here at the identity providers, you can see that I've already registered two identity providers, two social providers, Facebook and Google. And how this works is, let's say you want to build some kind of app and you want to use Facebook authentication in there. You will have to go to the Facebook developer console and register your app in the first step. After registering your app, you will receive an app ID or client ID with an app secret. And you will have to configure exactly these two values in here in order for EasyAuth being able to interact and validate your social token. So, for example, let's try to add another provider just for demo. I actually don't have the data for it, but it would work like this. Let's say we want to integrate GitHub authentication. So I would select GitHub here, and as you can see, I just enter the client ID and the client secret that I received after registering my app at GitHub. So cool, that's it. Built-in authentication is already enabled for my function app. Now let's take a look at the app part itself. And therefore, I'm going to switch to my app in this Android emulator. I've started it. And now I'm going to just click on login with Facebook. Let's see what happens. Cool. So some login screen opens in here in a web browser. And this opens in a web browser on the smartphone because I have not installed the actual Facebook app on my device. But if I would have installed it, it would just be a small pop-up that would come directly out of the app and asks me whether I would want to sign in with Facebook for this app. So in this case, I'm already signed in at Facebook, and it just asks me whether I want to continue. And I say, yes, I want to continue. And if everything works out, yeah, exactly. So a breakpoint hits, which I already expected, because at this point here, you can see that I'm making a very specific call. I'm using a so-called EasyAuth client and calling the function login with Facebook. So this EasyAuth client I built myself. And what I'm doing here, I've already received the Facebook access token. And I'm now sending it with the post request to Azure in order to exchange it for the Azure session token. We can also take a look at the Facebook token. And as you can see, this is not a JSON web token. But it doesn't bother us right now. Let's just continue. And there's the next breakpoint we want to take a look at. This is our actual post request, which we are now calling against the base URL of our function app /auth/login/Facebook, as we saw in the theoretical example. And the body, of course, also contains our social token that we received from Facebook. And if we continue and everything works out, the response should now include a valid JSON web token from Azure. This is the one I can now use for every further call towards our function app, and the communication will be then secure. We can also see that the body includes this user ID, which is unique for my user throughout in this context. Cool, so this authentication worked out. Let's continue again. We can see if we open the app up that we're actually logged in, and we automatically see the trips that take place within a radius of 25 kilometers right now around Linz. So this is cool. This is authenticating Azure Functions, but this is just half of the equation, right? This is authentication, but we still don't have any form of authorization. Let's say we create a trip. Now, only me as the creator should be able to edit or update the details of the trip, right? So we should find some way of authorizing the actual caller if he could or could not do and execute some functions. And let's take a look at that in the backend code. So this is my function app. As you can see, I've used the isolated process model for this Azure function because it gives me a bit more flexibility. I can modify the startup and register some middlewares, use dependency injection, and so on. And middlewares is actually exactly what we want to take a look at right now. Because if we go into this authorization middleware, which I implemented, we will see that some authorization work is done there. So this middleware is called every time a request is received, which goes towards any of our functions within this function app. And if we scroll down and take a look, what actually happens there is I'm searching here inside of the headers of the web request. I'm looking for a specific request header, which is called XMS client principal ID. Where does this request header come from? Remember, we're using a built-in authentication, and every web request that goes to my Azure function will now validate this Azure session token. And this easy auth, after successfully validating the token, just puts the user ID that is also included in the JSON Web Token as a request header inside the HTTP request. And the key for the header name is actually XMS client principal ID. So if everything works out, this easy auth user ID will now contain the actual ID of the user. And if we go a bit down here, we can see that I'm using my user manager to load the existing user with this user ID from our Cosmos DB database. If this user exists, I add the domain user ID of this user to the function context, because I'm able to access this function context or the items of this function context inside my function apps. I can use this ID in there to check whether I can or I cannot modify or update the details of a trip. As you can see, if we cannot find any user within our database, a forbidden exception is thrown, which produces a forbidden status code on the client side. And if you've seen, there's an if statement in the beginning where I'm looking for whether the called Azure function has a specific attribute called allow unregistered, because I have some Azure functions in here which do not require authorization and which I want to allow for every users. But let's go down this route. So we've added the user ID to the items of the function context. Now let's take a look at the function implementation, for example, for update trip. So in here, this is all the logic that happens in my Azure function. And at some point, I want to access the items of the function context and load this specific user ID. Then I'm going to convert it to a unique identifier. And this is a very trivial implementation. I'm just going to pass it on to my logic and let the logic do the authorization. In fact, if we go inside this update trip async, we will see that at this point, I'm checking whether the creator of the trip I want to modify, I want to update, has the same ID as the currently calling user. If not, I'm throwing a forbidden exception. Otherwise, I'm updating the trip data. So it's as easy as that. We've now seen authentication and also authorization. And we can get back to our slides, because that was already the fourth topic on our agenda. And what is left now is the recap and getting to your questions. So let's do a quick recap. What did we saw here? So we've worked with Azure Functions in combination with Cosmos DB. And what this really stands for is it helps me to focus on features. So if we remember of how we defined the data when we thought about querying the trip details, trip details, including the participants, we thought of putting the data into the trip object. And that helps me to get faster queries and to receive a resulting data model that exactly fits the feature that I want to implement. But also with the Azure function, I do not have to write lots of overhead code. In fact, the whole authentication is just a switch of a toggle and doing some configuration and registering the app at Facebook and so on. So it enables me to really focus on the feature itself. It is fast with regards to development, as we saw, and also with setup. So you can literally set up these few resources within a few clicks in a few minutes in the Azure portal without even using any ARM templates or any sort of things like that. Then the third point, it's cheap. So I've made a calculation, and with let's say with this existing app, if I would have, let's say, 1,000 users per day, this whole backend without the 3-tier would cost me literally less than 50 cents per month. So this is really a big advantage, I'd say. And what we've also seen, it's very adaptable and scalable. So both parts, the function app and the Cosmos DB, we could scale up really big. So if we talk about Cosmos DB, we've talked about it supports high availability requirements. So we could actually have redundant copies of every database separated over the globe. And the same goes for Azure Function. Cool. So that's it for now. Let's take a look if there's any questions, not that I can see. So I want to thank you for joining my session and also say thank you for organizing this event. Thank you for the guys of Global Azure Austria, and also my current technical coordinator who is working for this session in the background. I hope you had as much fun as I did, and I wish you a lot of fun with the remaining sessions for today. Thanks. Goodbye.